So we got a right angle. You also have two legs. The legs are the sides that touch the right angle. I didn't name the right triangle. I don't know why it's called that. I don't know. Here's the best part. The side that's across from the right angle, directly across, is called the hypotenuse. Again, not my idea. Didn't come up with it. Don't know why it's called that. If you figure it out, let me know. Don't look it up right now. So the longest side is called the hypotenuse. The two shorter sides that are touching the right angle, we call those the legs. And this only works for a 90-degree right triangle. Here's what we're going to do today. For problems 1 and 2, which is on the back of this page, you're going to do these things. You're going to draw little squares inside of each big square to show the area. I've already done that for you on this example. This is what it should look like. Find the area of each big square and write their areas inside of the big squares. So I counted up my squares on the side that has a 5, and I was like, well, there's 25 squares, so the area is 25. There's 16 squares here, little ones, so the area is 16. There's 9 squares here, the area is 9. You following me? Okay, you got to write that inside because we need to visualize it today. Today is all about seeing it. If you don't see it, then you won't understand it. Then you're going to add the areas of the two legs together and compare it to the area of the hypotenuse. So we're going to do that together. Add the areas of the two legs together. So the area of the leg, do this with me, on the side with a 3, we're going to put that here, is what? Would someone raise your hand and tell me? What's the area? Janiyah? 9. The area is 9, so I'm going to fill in the blank and put 9. Elise, what's the area of the square on the leg that's 4? 16. On my directions, it tells me add the areas of the two legs together and compare it to the area of the hypotenuse. So 9 plus 16, what does that give me, guys? 25. What? Okay, it gives me 25. Now we're going to answer questions A, B, and C, but we have to compare that number when we added what we got to the area on the hypotenuse. So I'm going to highlight so you really understand what I'm talking about here. I'm talking about that number to that number. Compare. Think in your head. How are they related? Someone feeling like they got this. How are they related? The sum of the two areas on the legs compared to the area in the hypotenuse. Tyler, how are they related?
They're the same thing.
Holy cow, they are. So you're going to answer these questions for me now. The first question asks us, how does the sum of the two areas of the legs compare to the area of the hypotenuse? Well, I notice that for less mathy people in here, the little square plus the little square equals what?
Big square.
The big square. That's what I noticed for this first one. That was my comparison. That says little. So that's what we noticed for this first one. And then we're going to ask, how is each side length related to the square on the same side? So in other words, if I go from a side length to a square, how do I do that? I'm going to write that down so you know what I'm talking about. How do I go from 3 to its area, 9?
Multiply. Or square root.
What am I multiplying by?
3.
3. I'm doing 3 times 3, which is the same thing as saying 3 squared. 3 squared is 3 times 3. This is a shorter way to write it. We say 3 squared is equal to 9. Because it tells me multiply 3 together twice. We talked about that when we did exponents. I think the rest you're going to catch on to. So if I want to go from 4 to 16, someone raise your hand, tell me how I do that. Juwan?
4 squared.
4 squared equals 16 because 4 times 4 is 16. So really all of these on the poster I could have written as 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, because squared is the opposite of square root. Okay? And then the last one, 5 to 25. What do I do? What do I do? Kanan, what do I do? How do I go from 5 to 25? In your own words. You don't have to use my words. What do I do to the 5? Multiply it by what? Right, which would be the same thing as saying what, Zachary? 5 squared. 5 times 5 is 5 squared. And so that's a shorter way to write it. From here on out, that's how you're going to see me write it. I'm not going to write 5 times 5 anymore. So now going the other direction, if I want to go from an area to a side length, think about what we talked about, your opposites. George, if I want to go from 9 to 3, how do I do it? But think about multiplication or division. Divide by 3. What's another way we could do that? Someone help him out. Elise? I could take the square root, which gives me the same thing, because I'm saying what number twice. So if I take the square root of 9, that gives me 3. So Desavion, 16 to 4, how do I do it? Square root of 16 is 4. And then the last one, Carmez, how do I go from 25 to 5? Boom. A 6 by 6 square, which is what's at the top here. Then I draw 5 lines. Watch. 1, 2, 3, 4, 5. Because that gives me 1, 2, 3, 4, 5, 6 sections. And then I draw 5 lines the other way. Because when you draw crisscrossing lines like this, now I should have a 6 by 6 square. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You count up how many squares that you have. Let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 12, 18, 24, 30. I have 36 squares. If you had to count each square individually, that's fine. But there's an example. If you're like, I don't know what you mean by draw the little squares. Now you do. Do it on your own. How does 100 compare to, that's the sum, how does the sum compare to the area on the hypotenuse? Sebastian, how does it compare? How does the sum compare to the area on the hypotenuse? It's the same. So we're seeing the same thing that we saw on the front. It's not a coincidence. So again, we'll say, I'm going to say it a little bit different this time. I'll say the sum of squares on the legs is equal to the area of the square on the hypotenuse. I'm using a little bit more technical language because eventually that's what I expect you to get to. Okay, let's answer these next 2 questions. How is each side length related to the square on that same side? So we're going from the side length to the square. So 6 to 36, 8 to 64, and 10 to 100. Riley, how do I go from 6 to 36? Yep, 6 squared is equal to 36. William Landreth, how do I go from 8 to 64? Square it. Brian, how do I go from 10 to 100? 10 squared. Okay. And then the last question here. How do I go from an area to a side length? So now we're going the other direction. 36 to 6, 64 to 8, and 100 to 10. Bella, how do I go from 36 to 6? How do I go from the big number 36 to 6? How do I go? How do I go from 36 to 6? I take the square root, because the square root is asking what number multiplied by itself gives me 36. So square roots here get us back to the side length. This is what you should have. If you don't have it, add it. That's important. So this is what that top problem looks like. You will notice the same type of thing happens on the one below it. You end up getting 169, 25, and 144. Well, 144 plus 25 is 169. Happened again. If I want the area of these squares inside of those boxes, I can take the length times the width. Since they're squares, the length and width are the same. So 5, that would be 5 times 5, which is 25. This one would be 6 squared, which is 36. So let's fill in that information on the box on the right. 25, 36. If I want to get the area of these square on the hypotenuse, the problem right now is I didn't give you a side length. But that's not really a problem because you should be catching on to a pattern. William Pace O'Neill, what do you think it should be? 61. So if I add the two areas of the legs together, I get 61. So that has to be the area on the hypotenuse. So here should be our final conclusion. Okay, before you write it down, let me explain just a little bit. So if I want to use variables instead of numbers, to get the area of a square, I just square the side. So the area of this one is a squared. The area of this one is c squared. The area of this one is b squared, because I've labeled my sides a, b, and c, like we saw at the very front. We discovered that if I have a right triangle, then the sum of the areas of the squares on the legs, so if I add these two smaller squares together, is equal to the area of the square on the hypotenuse. If I take the two smaller areas and I add them together, I get the area of the hypotenuse. That's what that says. And a short way to say it is a squared plus b squared equals c squared. Little area plus little area equals a big area. Pardon my kind of cursive. So that should say